Okay, working on practice problem 3 from recitation number 6. And this one also just gave me a run for my money. I had to sit down and really think about this one. It says calculate the osmolarity of a 500 milliliter parenteral fluid containing 5% weight per volume of sodium bicarbonate. And then it gives us the information. Okay, so I started looking at the information and I'm tired, and so I pulled out that there were 500 milliliters, and then the 5% solution, and the sodium and the bicarbonate. Then I wrote down that I had the milliosmol. Oh, it's per liter. And the equation for such is milliosmol per liter is equivalent to your weight per liter over molecular weight. And of course, that's in grams and grams per mole. And multiplied by the number of ions formed. Okay, so I wrote that down, and then I'm like, what do I do this with 500 here? Because if I do the 500 times the 5 over 100, that's grams and that's milliliters, then that crosses out, and then how do I get this liter? I had to sit and really think about what was I going to do with this 500, and finally realized that that was not needed information. It was in there to confuse us. The reason being is we are just asking for the osmolarity of this solution. It doesn't matter if the solution was a teaspoon or if the solution was a gallon. It's the osmolarity that counts, not the quantity at this point. So anyhow, that was my aha moment. I thought I would share in case there was somebody else who needed an aha moment of that. Anyhow, I've already written down my formula, so at this point I'm going to plug and play. I am going to remember that I do need to include my number of ions formed, and I need to remember that tomorrow. I just did a problem where I forgot to include the valence in my formula, so prone to mistakes, not cool, but hopefully tomorrow will be better. Exam is tomorrow. Anyhow, let's see here. My milliosmol I'm going to call S, and that's going to be per liter, but that's what I'm going to end up with, is going to be equal to my concentration, so that's going to be 5 grams per 100 milliliter. Divided by my molecular weight. My molecular weight is going to be 84 grams per mole. And I am going to multiply that by my number of ions formed. And let's see here, we got some things that do cross out, and that's great. And I just realized too that I am specifically looking for liters when I'm all said and done. So I'm going to go ahead and take care of that right now. There are 1,000 milliliters in a liter. Those are going to cross out. And there are, let's move this over so I can make sure I have plenty of room here. There are 1,000 millimole in and that's upside down, 1,000 millimole in a mole, and those are going to cross out, and looking good here. So then I also noticed that I'm going to have 1 milliosmol per millimole here, and my millimoles are going to cross out, which is going to leave me with milliosmoles per liter. Now it is just a matter of doing my math. So I'm going to have 5 times 2 times 1,000 times 1,000 divided by 100 divided by 84. That is going to leave me with 1,190 point, let's call it 5 milliosmol per liter. Any questions? Let me know. Thanks.